one good day, Algebra, going over PO59 with you, which is one of the most important mathematical formulas you'll ever learn. Let me put it like that. It's called the quadratic formula. And what it's used for is to solve for the x-intercepts of a parabola. And you might be thinking, wait a minute, we already solved for x-intercepts of a parabola, right? We spent 3 days on PO55 going over the 3 different ways to solve for the x-intercepts of a parabola. Why do I care about this? Well, if you remember, particularly with the factoring method, you had some of them that weren't factorable. They were prime. And at that time, I said that it doesn't mean it's not a parabola. It doesn't mean there even aren't any x-intercepts. It just means it's not factorable, because not every parabola is. So the quadratic formula gets us around that. The quadratic formula will always work, no matter what your equation is, whether it's ax squared plus c, which is typically the order of operations, whether it's ax squared plus bx, which is GCF, whether it's ax squared plus bx plus c, which is factoring, it will always work. So am I telling you that you can essentially forget everything you learned about PO55? Well, yeah, kind of, because PO59 is all you really need to know, okay? And the quadratic formula is this. Negative b plus or minus the square root of b squared minus 4ac, we recognize that, there's our discriminant, all divided by 2 times a. Negative b plus or minus the square root of b squared minus 4ac, all divided by 2 times a. It's a doozy. It's a doozy. It does. It puts them all together. You recognize here the negative b over 2a. That's part of it here. You recognize the discriminant. That's part of it here. We've talked about the plus minus sign. That's what gives us our 2 answers. Because to get one x-intercept, you'd add the root of b squared minus 4ac. The other x-intercept, you'd subtract the root of b squared minus 4ac. It kind of puts everything together. This is the feast. This is the culmination. Okay? And we can use this to find the x-intercepts of any parabola. And so let's just begin, shall we? Let's not put it off any longer. Let's go. Okay. Our first one. Look at how much space I gave you to work, too. You know it's a good one when you have that much space. X squared plus 5x minus 104 equals 0. What you might want to do before you start is you're using a, b, and c. Just jot down what your values for a, which in this case 1, b is positive 5, and c negative 104. Jot down what they are, just so you have them. I mean, you can obviously see them from the equation also, but some people like to have them kind of separated here. And so we're going to start. Let me write the quadratic formula here again. Negative b plus or minus the root of b squared minus 4 times a times c all over 2a. And we're just going to plug these values in and watch the magic happen. Okay? So our numerator, negative b, that's going to be negative 5. All right, plug in 5 for b there. Plus or minus the square root of 5 squared minus 4 times a, which is 1, times c, which is negative 104. Again, that discriminant piece, we've already kind of done that before. And all of that is divided by 2 times a, which is 1. And now it just becomes a whole lot of algebra, really. Okay, order of operations. You can't really put this whole thing in your calculator at once. If you do, it requires a whole bunch of parentheses, so it is possible, but it's probably best, especially learning it for the first time here, focus on the root first. Okay, don't try and solve the whole thing at once. Take it piece by piece. So our next step here is going to be negative 5 plus or minus the root, and solve that discriminant. What is 25, which is 5 squared, minus 4 times 1 times negative 104? Everyone calculate that out. 25 minus 4 times 1 times negative 104. I got 441. Is there a second on that? Okay. So negative 5 plus or minus the root of 441. And we can simplify our denominator as well. 2 times 1 is just 2. Okay. Now 441 is a perfect square. It ends up being 21. So let's do that next. We have negative 5 plus or minus 21 divided by 2. Any questions on how I got to where I'm at? Soybe.
It's not really about where you're at, but what does the plus or minus mean?
That's where we get our two answers here. Because remember, we're looking for two x-intercepts. So once we get down to this step here, now we're going to use the plus minus symbol to get our two answers. Okay, so that's coming next. Other questions on how I got to where I'm at? Okay, so we've simplified the root. We've got here, we can't really go any further the way it's written. So our two solutions, our first solution is going to be negative 5 plus 21 divided by 2. And our second x-intercept is going to be negative 5 minus 21 divided by 2. The only difference between those two things is in the first one I use the plus sign, the second one I use the minus sign. Okay, but it's that plus minus symbol in the formula that gives me those two answers. Now, if you're going to your calculator and you go to your calculator for that first solution there and you type in negative 5 plus 21 divided by 2, you're going to get the wrong answer. Why? You can do everything else right. You can do the hard part right. But if you put it in your calculator, this expression like that, you're going to get the wrong answer. Audrey, why? Right, because the order of operations, which you've told the calculator to do, is divide 21 by 2 and then take negative 5 plus that answer. That's not what this expression says down here. Remember, when you've got something written as a fraction, they aren't actually there, but there are parentheses around the numerator and the denominator. So in your calculator, you need to put negative 5 plus 21 in parentheses so that you divide the whole thing, that whole numerator, by 2. So negative 5 plus 21 is a positive 16. 16 divided by 2, we get 8 as an answer. Okay? The second one, same thing. Negative 5 minus 21 in parentheses. That gives us negative 26. Negative 26 divided by 2, our second x-intercept is negative 13. There's your first experience with a quadratic formula. Already in love? Okay. The fact that we got two integer answers here, meaning no decimals, means that the original equation was factorable. Okay. But I wanted to start with one that worked out nice and easy here, just so you can see the process. Most of the time when you need to use the quadratic formula, it'll be because your x-intercepts are decimals because the original equation wasn't factorable. Okay? But if you don't like factoring, then here you go. Alternative method. All right? What's that? Good. It makes me feel smart whenever I use it. Okay? Let's. Anyone else need these notes? I'm going to erase these so I can have a little more space for the second one there. Anyone else need them? Going once, going twice? Okay. Let's look at the second one. Again, I'm going to identify my A, B, and C. My A is 2, my B is 6, and my C is 5. And I'm going to write the quadratic formula up here again, just so we have it. Negative b plus or minus the root of b squared minus 4ac, all divided by 2a. And we're going to start plugging stuff in. My b value is a 6, so in the formula it's going to be a negative 6 plus or minus the root of 6 squared minus 4 times 2 times 5, all divided by 2 times 2. The first step is just plug the numbers in. Replace b with b, replace a with a, replace c with c, plug it all in. Now we start to simplify, and again, we're going to simplify just the root. We're not going to take the whole thing at once, okay? We're going to take it piece by piece here. So that -6 plus or minus the root, 6 squared minus 4 times 2 times 5, 6 squared is 36. We get 20 times 2. So we get 36 minus 40, all divided by 4. Huh. Well, what does that give us inside of our root? A -4. We've talked about taking the root of a negative number before, right? Doesn't work out until Algebra 2 when we just imagine them, okay? Why does it make sense that we would get a negative number here, and since we can't take the root of a negative number, it means that there are no x-intercepts? Elise?
Because then it's a negative in b squared minus 4ac.
Exactly. b squared minus 4ac being the discriminant, if that equals a negative number, the reason why it works if there are no x-intercepts is because then we are expected to take the root of that negative number, which can't be done. So the discriminant being negative, the reason why we didn't care what the number was, only the sign, is because it doesn't matter what the number is. If it's negative, you can't go any further because you can't take the root of that. Okay? If b squared minus 4ac is positive, you can take the root of any positive number. Might not be a perfect square, but you can take the root of any positive number. That's why for positive numbers, there will be 2 x-intercepts. So if you solve the root or simplify the root and you get a negative number there, it means that there are no x-intercepts. Your life just got a lot simpler because you're done. Okay? Doesn't mean it's not a parabola. Still a parabola. But it doesn't cross the x-axis. Okay? I get no x-intercepts because of this right here. The root of a -4. If you take the root of a -4 in your calculator, it'll give you an error. It'll say non-real answer because the root of -4 is an imaginary number. Seriously. Yep.
Do we just make up the number?
No, you imagine that it crosses the x-axis. Remember what the solution to this actually is, though, in all mathematical seriousness here? If you were to get this on your map test on Tuesday and it asks you for the root of a -4, what would the answer be? Something I. It wouldn't be -2i, it would just be 2i. Okay? It'd be 2i. But you don't deal with imaginary numbers until Algebra 2. But if you happen to get it on your test on Tuesday, you can impress the map people by answering that with a 2i. If it's the root of -9, it's 3i. If it's root of -25, it's 5i. So the math is still kind of the same, but we add that I on the end of it. Anyway, you don't care. Okay, let's go on to the last one here. -4x squared minus 5x minus 1 equals 0. My A term is negative. My B term is negative. My C term is negative. A lot of negativity here, but we're going to make the best of it anyway. So plugging it into the formula, we've got a negative B, which the fact that my B value is negative as well, kind of the same thing that happens with the vertex formula. It ends up being a +5 out in front. Okay? Just like with that vertex formula, if your B is negative, a negative B or a -5 makes it a +5. And then under the root, we've got -5 squared minus 4 times our A value of -4 times our C value of -1. And all that is divided by 2 times -4. All right. So, simplifying the root first, we've got 5 plus or minus the square root. -5 squared is +25. -4 times -4 times -1 is a -16. So 25 minus 16 is 9. So we have 5 plus or minus 9 divided by negative 8. After you simplify all of that stuff. Any questions on how I got to where I'm at? All we've done so far is simplify the root, which is an order of operations nightmare, but you can do it. Okay. Now that we're here, we're ready to break it up into our two. Yes.
Wouldn't it be plus or minus 3? Because then I should still be under the root.
Yeah, that's what I thought.
Well done. Well done. It would be. That root, we have not taken the root yet, and so it is 5 plus or minus root 9. Times like these, I really wish I knew how to edit these things, but I don't. So if anyone actually watches these, they'll get to laugh at my mistake. So yes, technically it is going to be 5 plus or minus 3 divided by negative 8. Usually you wait until I'm at the end of it to show me I made a mistake. So thank you for at least doing it now. But yeah. Okay, now we're ready to break it up into our two solutions. Our first one, 5 plus 3 divided by negative 8, which if you use your calculator for this, you can do this one mentally, but if you do, make sure you put parentheses around that numerator, 5 plus 3. And our second one, 5 minus 3 divided by 8. So our first one, 8 divided by negative 8, we get an x-intercept of negative 1. Looks like x equals y. I should make that better. X equals negative 1. And our second one, we get 2 divided by 8. So x equals 0.25 or the fraction 1/4. Okay, questions on any of this? All right, let's look at the next page and see how long this, if I give you just one page to practice with here. Give me one that you'd like to do here. Any of them are fair game, whatever you want. Floor is yours. Olivia. Second row, middle one. 5x squared minus 3. And this is why, I'm a meanie. Is that what you said? This is why it might be helpful to identify your A, B, and C first, because this equation does have a B value. It's 0. Okay? Our B value here is 0. Our A value is 5. Our C value is negative 3. And you know it's the B value that's missing here because that B is always the coefficient to x. There is no x term. Therefore, the B value is 0. So plugging this into the formula, we've got negative B, or negative 0, which is just 0, plus or minus the root of B squared, or 0 squared, minus 4 times 5 times negative 3, all divided by 2 times 5. Okay? And since we've got 0 plus and 0 minus, we are going to come back to that. We'll use that. But what do we already know about what our solutions should be here? Based on the form this equation is, there is no B term. What do we know about the solutions for the x-intercepts of this parabola? It is a parabola. It's got the x squared term. That's what makes it a parabola. What do we know about the x-intercepts? The discriminant's going to be positive, so there will be 2 x-intercepts. This form, ax squared plus c, remember your 2 x-intercepts will be opposites. Okay, they'll be opposites, so expect that to happen here. Simplifying things, we've got 0 plus or minus the root. 0 squared is just 0, and then negative 4 times 5 times negative 3 is 60. So we have 0 plus or minus the root of 60 divided by 10. And lo and behold, 60 is not a perfect square. So this would mean that this would be a non-factorable equation here, which is why the quadratic formula is a good method to use. So we go to our calculator, we calculate the square root of 60 to be approximately 7.75. It's actually 7.7459666692, but we're going to round that to the nearest hundredth. So 7.75. Okay, and so we get 0 plus or minus 7.75 divided by 10. And now we can break it up into our two solutions. I'm going to go below here so I don't cram the writing. 0 plus 7.75, which is essentially just positive 7.75 divided by 10. Our second one, 0 minus 7.75, which is essentially negative 7.75 divided by 10. And so our x-intercepts, our first one, rounded to nearest hundredth, is a positive 0.78 and a negative 0.78. And you see they are opposites there, which they should be based on the form of the equation we have. Okay? This makes PO50 look like tiddlywinks. Huh? Remember when you thought solving for ox and oy was hard? Huh? A lot of work? Welcome to the quadratic formula. I dare you to not enjoy this, which you already said you did, so I guess I win. Okay. Any other questions on this process? Any other? We got about 10 minutes left. We'll go over one more in class today. Any that you want to tackle? Swicky. Of course, why not? The last one, we have x plus 13 squared equals 25. It's not in quadratic formula form because it doesn't equal 0. There's also no x squared term. So like we've seen before, our first step is we're going to have to put it in the form that we want, meaning we have to figure out how to scroll down, not too far though, because there we go. We're gonna have to crab claw foil box x plus 13, because remember when you square a set of parentheses, you're literally taking x plus 13 times x plus 13. So that gives us x squared plus 26x plus 169 equals 25. But in order to use the quadratic formula, our equation has to equal 0, just like any other time when we want to get the x-intercepts. So we're going to move that 25 over, and that's going to give us x squared plus 26x plus 144 equals 0. And now you can get to the quadratic formula from there. Okay? Does that answer your question? Good? Okay. All right. Your homework for tomorrow is to do 2 of them from this page on your own. Okay? I'll give you a preview. Your homework for Friday is going to be to complete the page. All right? Tomorrow we're on a math schedule, so you have shortened class anyway. So for Friday, we'll kind of go over this tomorrow, make sure we're all on the right track. You'll finish it up for Friday. So if you want to just get it all done, have no homework tomorrow with con due tomorrow, maybe tonight's a freer night for you. If you want to roll through it, then you can. I forgot to mention, oh my gosh, shame on me. How would you check your answer here? For the one before this, we got 0.78 and negative 0.78. How would you check your answer to make sure you're right? Because after doing all that work, I mean, you want to get the answer correct. How would you check it? What? Oh, I thought I heard something. Julia? Yes, you'd plug them each into the equation separately because they're 2 different values for x, and your equation should equal 0. Now, if you try this and you plug in 0.78 in for x, 5 times 0.78 squared minus 3, the answer I get is 0.042. Did I do it wrong? Why not?
I got one above.
because you rounded.
Oh, wait, never mind.
Right. This 0.78 is a rounded value. And like we've talked about before, in both algebra and geometry, when you use a rounded value, you lose some accuracy. So the fact that I don't get exactly 0, but I get something that's really darn close, I'm okay with that. Okay? Because I know that using this rounded value will slightly affect that. If I were to do this and I got something like 1.5, that's too far away. Okay? Rounding to nearest hundredth will not get you a whole 1.5 units away from 0. Will it get you, 42 thousandths units away from 0? Yeah. Okay. So when you check these. Oh boy. When you check these answers, expect that if you round it, it's not going to be exactly 0, but it should be close enough to where you can be confident that you are correct. All right. Anything else? Okay. To do tomorrow, your choice. In addition to what we did, so you can't count the middle one as one of your 2 because we did that one together. So 2 additional to the middle one there. You can do the last one if you want to because we didn't actually finish it out. But 2 of them due for tomorrow. That's all I got. That's all you math.